Okay, so factor out the GCF makes it a quadratic. Once you have a quadratic, then you can factor it. This is the most critical part of the entire process. You have to pick the proper x terms. And what I'm seeing is that you're picking the right numbers, but you're assigning the wrong value. So a lot of times you're saying it's -4 and +6, added up gets you -2. It's just a quick, easy, simple mistake, but slow down. Once you have your x terms, what should be your next step? To write it into the equation, either using the box method or the grouping method, right? Either the grouping method or the box method. Let's just use box, it's easier. So with the box method, I end up with 8x squared minus 3, -6x, +4x. I pull the GCF out right here. What's the GCF of these two guys? 2x. That makes that 4x plus 1 minus 3. Now what that means is this. Your factors of this are x times 2x plus 1 times 4x minus 3. And if you did not put that x out front, it is wrong. Why? That's exactly right, guys. If you don't have the x and you multiply these binomials, you will not get that. You have to be able to get back to where you started. And the x is the only thing that allows you to do that. By the way, this is your answer, because I did not ask you to solve it, I asked you to factor it. That's your answer. Any questions on that? Yesterday we learned about this zero product property rule. And what we learned is that on this one, is there anyone in the room who could mentally just come up with crazy math skills that tell me what value of x makes that true? I could, but is there anyone else? Luke, you cannot.
Yes, I can. I did it.
Sure you did. That's interesting. Looks like you factored it.
No.
Okay. So anyway.
That was the other.
Okay. Here we go. So when we factor it, what's the first thing we do when we factor it? After we look for GCF, what's the second thing? A times C. A times C in this case is -60, so we're looking for two numbers that when multiplied get you -60, and when added gets you +7. If you did it right, it's 12 and 5, and which one gets the negative? The 5 gets the negative. Very good, because when you add them, it has to be a positive number. So we have 12x and -5x. I'll still do this. I know. If y'all do grouping, you're perfectly fine. I just prefer this. 12x, -5x. Start there. The GCF here is 2x. That makes that x minus 5 plus 6. Make sure that works, and it does. My factors are x plus 6 and 2x minus 5, and that equals 0, which means x is what? -6 and 5 over 2. Very good. -6 and 5 over 2. Questions on that? Cool. Today you will need a calculator. Make sure you have one. Go ahead and clear it, please.
Can you get a calculator?
Guatemalan. Eastern Guatemala. Western Guatemala is a whole different accent. I know. So by the way, if you see me walking around kind of like holding my hand up, it's because, okay, did I tell you I got bit by my dog last week? Okay, I got bit by my dog last week, and then it got, no, the old grumpy one that I should throw in the garbage can. But he just decided randomly he didn't want to be picked up. He bit me. It's a big, long story. It doesn't matter. But then it got infected, so I had to go to the doctor, and the doctor gave me antibiotics. So I started taking the antibiotics on Friday, and then took them Saturday, and took them Sunday because it's once a day, whole lamb. And then everything was much better. Like by Sunday night, you couldn't even tell. It like felt good. I could bend my finger, no problems. So because of my advanced medical training and the fact that I'm a doctor as well as a math teacher, I just decided I don't need to take the medicine anymore. right? Because of all my experience in the medical field. I just said, I don't need to take the medicine anymore. It woke me up this morning with the most excruciating pain, and my finger is like jacked. Look how swollen it is. It's now, the infection is now in the knuckle of my finger, which means it's pinching on nerves. So I'm actually having pain all the way up to my elbow because I'm an idiot. According to my wife, Miss O'Grady, Mrs. Perry, Dr. Evans, and his nurse Bertha, all of whom have called me an idiot at some point today. So I'm elevating my hand so as not to cry in front of you. Aaron Lamb, what? No, my dog has shots. I think. So if I start crying or foaming at the mouth, you should run. Okay. So here we go. Today we're going to learn how to solve a quadratic. Now, today is about listening and not working ahead. I'm making my way to the back of the room. I'm just making my way randomly to the back of my room to make sure that everyone knows that today is about conversation and listening and not working ahead. Because if... So here's what we've got. When you're asked to solve a quadratic, you need to understand, first of all, how many different ways I can ask you that, because there are about four. 4 different ways I can ask you to solve a quadratic, and you need to know that they all basically mean the same thing. They just sound very, very different. And there are kids who have come up, who have read for me on a test where I've said, solve the following quadratic, and they've solved it. And then the 2 questions later, it says, find the zeros for the following quadratic, and they have no idea what I'm asking them. But it's the same thing. Because in order to solve a quadratic, I can say, find the roots. I can say, find the zeros. I can say, solve it. Or I can say, find the x-intercepts. And all of those things mean the exact same thing. They will not change how you find the solutions or the roots or the zeros. It's all the same thing. So you need to understand that. You also need to understand how to find them from a graph, how to find them from a table, and how to find them from an equation. We're going to start with an equation, then I'm going to show you what that looks like in all the other forms. When it says to solve a quadratic and it gives you the equation, first thing you do is make sure that it's equal to 0, set it equal to 0, and factor it. So what we end up with is x squared minus 3x minus 4 equals 0. Now, go ahead and factor this. And we're looking for 2 numbers. Remember, we do A times C. So we're looking for 2 numbers that when multiplied gets you -4, and when added gets you -3. What 2 numbers multiplied gets you -4 and added gets you -3? Luke?
-4 and 1.
-4 and 1, perfect. -4 and +1. Now, take your time on that one to make sure it's right, especially the addition part, because that's usually where the kids screw up. Now, I want everyone to look up really quickly and not to forge ahead factoring. This is why I say, stay with me. There is a shortcut that you may employ when the A value is 1. You can only do this when the A value is 1. Where is our A value? It's in front of the x squared guy, right? Is the A value 1 in this quadratic? It is, so watch what you can do. Only when the A value is 1. Thank you. Now, we found our numbers, right? It's -4 and +1. -4 and +1. Everyone agree? Here are your factors. X minus 4, X plus 1. You don't have to do the box method. You don't have to do grouping. You just put them into the binomials. Okay. If you still want to do the box method, feel free. You'll end up with that. If you still want to do grouping, feel free. You'll end up with that. Only when the A value is 1, once you find these 2 guys, you just put them there. Done. End of story. Now that means that the factors of this quadratic are x minus 4 and x plus 1. So I'm going to put them down here. X minus 4 and x plus 1. Now, in order to find the solutions to the quadratic, we are going to use the zero product property rule We're going to use that zero product property rule, and we're going to find the values of x that both of those are 0. It's a z. Zero product property rule. Now, in our original equation, well, here, let me back this up. Based off of the zero product property rule down here, what value of x makes this equal to 0? 4. What value of x makes the second one equal to 0?
-1.
Wow, you gotta hate it when that happens, don't you, Luke? Just throwing out that maybe tapping the brake before, you launch. 1! Negative. Something. Okay. Okay. It's like watching someone try to stop themselves from rolling down a hill. It's just a catastrophe. Okay, so 4 and -1. Now I want you to begin to see what it looks like everywhere else. So here's what I want you to do. I want you to punch in your quadratic into your calculator. And then, Luke, enough, I want you to go to the table. Yeah, go to y equals. Go to y equals and type in x squared minus 3x minus 4. And when you go to your table, hopefully you cleared it first, I would like for you to please write down all xy ordered pairs from -1, x equals -1 to 4. I want you to write down all the ordered pairs from x equals -1 to x equals 4. Now, what do you notice about these particular points on the table? They're both the x-intercepts. They're where our y value is 0, -1, and +4. Those are called your solutions. Those are called your roots. Those are called your zeros. Yes. And the reason that is because at the very beginning, we set what equal to 0. We set the whole equation equal to 0, but what variable did we set? We set the y equal to 0. Because f of x is the same as y, and we made it equal to 0 right there. So we made the y value equal 0. Which means the solutions to your quadratic are always going to be found where your y value is 0. Now, in order to find it from an equation, you're going to factor it, and you're going to use the zero product property rule to find those numbers. That also means that your x-intercepts are at 4, 0 and at -1, 0, because your y value is 0. And on a graph, here's what your graph is going to look like. Let's use the table. We have -1, 0, which is right there. We have 0, -4, which is right there. We have 1, -6, which is right there. 2, -6, 4, and that. Now, there's one very, very important piece of information that's missing that you need in order to graph it. Anybody have an idea what it is? What is it, Aaron? You must have the vertex, because your graph does not go flat between these 2 points. So you have to go back. And by the way, does anybody know where my vertex is based off my table? Yeah. It's right here. That's where my vertex is, because that's where I see symmetry. Which means that if I just look where the x value is 1.5, which I can do with my calculator by hitting second window and typing in 1.5, then going back, it's very good. It's -6.25. That is my vertex, which means my graph should dip down just a little bit when I draw it. And if it doesn't, I'm counting it wrong. Now here we go. I'm going to connect all these. That's my parabola. Which means from a graph, where would I look to find the roots? I look where it hits the x-axis. Those are my solutions, my roots, my zeros. So what I need you to be able to do is if I give you a graph and say, what are the zeros for the following quadratic? You're going to look where the x-intercepts are. If I give you a table and I say, find the solutions, you're going to look where the y values are 0. If I give you an equation and I say, solve the following quadratic, you're going to factor it, you're going to set the factors equal to 0 and give me those x values. Any questions? Do the second one yourself. Yes, sir.
So on the table, would you just go, would it always be -1 through 4, or would you change the heat based on the zeros?
You change it based off where your vertex is. Guys, remember, I want your table based off your vertex. Okay? I want your table based off your vertex. And there are some times where you can find it with your table. There's sometimes you can't find it with your table. Sometimes you can find it with your graph. Sometimes you can't. You can always find it with the equation. Don't forget to change your table set back to 0 before you get too invested in the next one. Remember, anytime you change that table set, you want to go back. And when I draw the table this time, not including a whole lot of points, including -2, 5, -1, -3, 0, -3, 1, 5. Can we find the solutions from the table this time? You cannot. Can you find out kind of where they are from the table? Where would the y values become 0 based off the values of y? Between 5 and -3, and between 5 and -3. Because when you're going from a negative number to a positive number, don't you have to cross 0? Yeah, so I know my solutions are somewhere there and there. I know that. Now, if this was a test question, I would need to find them another way. Now, what they might say is they might say, between which x values do the solutions to this quadratic lie? Then you say, well, I know the solutions are between the x values of -1 and -2 and 0 and 1, right? That's a great test question. Because some of you will come and go, Mr. Smith, I can't find the solutions. But that's not what it's asking you. It's saying, where are the solutions? In this case, they're between here and here, and here, and here. And did they end up being there, by the way, when we really found them? They did, because negative 3/2 is right here, and 1/2 is right there, right? So same thing on the graph. Negative 2, positive 5 is right here. Negative 1, negative 3. This is a very narrow parabola. 0, negative 3. That's a very narrow parabola. But before I graph it, what must I find? Vertex. Vertex is right in here. So the vertex is at negative 0.5 something, right? So again, I go to second window, I type in negative 0.5, I go back to my table, and it's at negative 0.5, negative 4. So that means my vertex is right there. Now I can graph. And there you go. Again, what I need you to walk out of here understanding today is this. I need you to be able to look at a table and tell me where the solutions are. In a table, how are we looking for the solutions? What are we always looking for? No. Yes. X-intercepts, which means where y is 0. I'm looking for where y is 0. On a graph, how am I looking for the solutions? Where it crosses the x-axis. Right here and right here. And from an equation, I'm simply going to factor it. Guys, listen to me. You have classwork and homework. However, the classwork only has 2 questions on it. The homework only has 2 questions on it. So take your time and check the key. Okay? And then you're good to go. 7th graders, remember, by Monday I want those EOCs. I know.